Comprehension. Ferrous sulfate solution undergoes aerial oxidation to give ferric sulfate, and ferric sulfate acts as an oxidizing agent. Ferrous oxalate solution gets oxidized by KMnO4 in acidic medium. A sample of ferric sulfate and ferrous oxalate was dissolved in dilute sulfuric acid, and it required 40 ml of N/16 KMnO4 for oxidation. After oxidation, the reaction mixture was reduced by zinc and dilute sulfuric acid. 60 ml of same KMnO4 solution is required for the oxidation of the resultant mixture, and the molecular weight of ferric sulfate is 400. Now let us answer the questions given. The ratio of millimoles of ferrous oxalate to ferric sulfate in the original solution is it 4:7, 7:4, 3:5, 4:5? Let A millimoles of ferrous oxalate and B millimoles of ferric sulfate are present in the mixture. During the oxidation with KMnO4, the ferrous ion from ferrous oxalate get oxidized to ferric ion with an N factor of 1, and oxalate get oxidized to carbon dioxide by acidified KMnO4 with an N factor of 2. Thereby, the total N factor is equal to 3. That is, A millimoles of ferrous oxalate will now become 3A milliequivalents of ferrous oxalate, and this is ferric sulfate. B millimoles of ferric sulfate will give 2B millimoles of ferric ions into the solution, but these ferric ions do not get oxidized by acidified KMnO4. So in the first instance, when the mixture is taken ferric sulfate and ferrous oxalate dissolved in dilute sulfuric acid, it required 40 ml of N/16 KMnO4 for oxidation. This 40 ml of N/16 KMnO4 is used only for ferrous oxalate to get oxidized to ferric ions and carbon dioxide. Therefore, for 3A milliequivalents is equal to 40 ml of N/16 KMnO4 in acidic medium. Therefore, 3A is equal to 40 into 1/16. 8 2s, 8 5s, 5/2. Therefore, A is equal to 5/6. That is, millimoles of ferrous oxalate in the solution is 5/6. Now, after oxidation, the reaction mixture was reduced by zinc and sulfuric acid. 60 ml of same KMnO4, that is 1/16 KMnO4 is required. So this KMnO4 of 60 ml is used by what? So after this oxidation, that is after oxidation, we have A millimoles of ferric ions, ferrous oxalate, and 2B millimoles of ferric ions from ferric sulfate, which on reduction A plus 2B millimoles total with zinc in the presence of sulfuric acid get reduced to ferrous ions. That is, A plus 2B millimoles of ferrous ions are now present. Now, that is, A plus 2B milliequivalents of ferrous ions will now get oxidized to ferric ions by KMnO4, for which purpose 60 ml of N/16 KMnO4 is required. Therefore, A plus 2B milliequivalents is equal to 60 ml into N/16 KMnO4. But we know what is A, 5/6. Therefore, 5/6 plus 2B is equal to 60/16, which is 4 4s, 4 15s, 15/4 milliequivalents. Therefore, 2B is equal to 15/4 minus 5/6. This comes out to be 35/12. Therefore, B is equal to how much? 35/24. So we got now A and B. What is asked in the question? The ratio of millimoles of ferrous oxalate to ferric sulfate, that is A is to B, is asked. Therefore, A is to B is equal to 5/6 is to 35/24. So this is 5 1s, 5 7s, 6 is to 24, that is 4 times. Therefore, A is to B is equal to 4:7. This is what we are asked to find. So the answer is 4:7. So A is the right answer.